Okay, let's do this question together. All right, simplify tan 315 degrees times sine negative 315 degrees minus cos 45 degrees. So if you look at this expression here, what do you think are the concepts that we need to remember here? Okay, tan 315 degrees, you see that? We have to use a reduction formula there, okay? Right, sine negative 315 degrees, we have to use negative angles and the reduction formula, and then this is a special angle, so we may be required to use reduction formula, negative angles, and special angles. Right, before we look at this question, I want us to discuss these three concepts. I want us to discuss reduction formula, and then negative angles, and then special angles. Okay, let's look at the reduction formula. Right, this is our Cartesian plane. So we have angles that are between 0 degrees and 90 degrees. Okay, these are angles like 30 degrees, 40 degrees, 60 degrees. They are angles in quadrant 1. We say this is quadrant 1. These are acute angles. And then we have angles that are between 90 degrees and 180 degrees. These are obtuse angles. Angles like angles like what? 150 degrees. 100 degrees, 120 degrees. They're in quadrant 2. They are on the second quadrant. You see that? And then, so how do we write these angles in trigonometry? Reduction formula, we say 180 degrees minus theta. They are 180 degrees minus theta. Like for example, let's say 120 degrees is in quadrant 2, isn't it? How do we write it? Is like this. If we want to express it like this, we say it is 180 degrees minus 60 degrees. You see that? Because 180 degrees gives you 180 degrees minus 60 degrees gives you 120 degrees. You see that? Okay. Right. And then where there are angles that are between 180 degrees and 270 degrees. They are in quadrant 3, in the third quadrant. So how do we write them? We write them as 180 plus theta. These are angles like 200 degrees. Okay, let's take, for example, 200 degrees. How will you write it? We're going to say 180 degrees plus 20. You see that? Because 180 degrees plus 20 is 200 degrees. You see that? Okay, so this is the third quadrant. And then we have angles between 270 degrees and 360 degrees. We've done the complete revolution now. These are in the fourth quadrant. Okay, we talk of angles like 300 degrees, 350 degrees, or 315 degrees. You see that? So they are in the fourth quadrant. How do we write them? We say 360 minus theta. Okay, so for example, let's say 300 degrees. How will you write 300 degrees? It's going to be 360 degrees minus 60 degrees, which is equal to 300. You see that? So we can write them like this. Okay, right. So you can maybe pause the video here and write these angles. In the first quadrant, we have our theta. In the second quadrant, we have 180 degrees minus theta. In the third quadrant, we have 180 degrees plus theta. And then in the fourth quadrant, we have 360 degrees minus theta. Okay, right. I want us to look at the trigonometric ratios in all these four quadrants. Right, so in quadrant 1, we have our three trigonometric ratios. See that? Okay, there's nothing there. It's already, the angles are already what? Acute angles. Theta is the acute angle. Remember, when you are doing reduction, you are reducing the obtuse angles or reflex angles to acute angles. Okay, right. In the second quadrant, we have these three trigonometric ratios: sine theta. Okay, it's not sine theta. Sine 180 minus theta. It is equivalent to sine theta. You see that? Positive sine theta. And then cos 180 degrees minus theta is equivalent to negative cos theta. And then tan 180 degrees minus theta is equivalent to negative tan theta. That is in the second quadrant. Okay, right. And then we can discuss how these signs come about. Okay, remember that sine theta is equals to y over r, and then cos theta is equal to x over r, and then tan theta is equals to y over x. Okay, I'll just discuss the second quadrant here, then the rest I'll just tell you. Right, like in the second quadrant, the y coordinates are positive, and r, remember the ray is always positive, so it is positive over positive. That's why sine theta here is going to be positive. You see that? And then cos theta in the second quadrant, x is negative and r is always positive, so it's negative divided by positive. That's why cos theta in the second quadrant is negative. And then tan theta is y over x, and then in the second quadrant y is positive, x is negative, so it's positive divided by negative, making it what? Negative. Okay, so we can explain using all this in all the quadrants. Okay, but just know that in the second quadrant it is only sine 180 degrees minus theta that is equals to positive sine theta. The other two are negative. Right, and then we go to the third quadrant. It's the same thing, but now it's going to be this one, which is going to be positive now. Tan 180 degrees plus theta is equal to tan theta. This is positive. And then the other two are what? Are negative. Okay. All right. And then we have the last quadrant. Okay. It is going to be this one, cos 180 degrees minus theta, that is equal to positive cos theta. But these other two are what? You can see they are negative there. Okay, but there's an easier way to remember this. We call it the cast diagram. You know, the cast diagram. There's an easier way of remembering this. So if you check here, all of them are positive there in quadrant 1. And then in quadrant 2, it is only sine 180 degrees minus theta, which is positive. So we say sine there, which is positive. We put S there for sine. And then in quadrant 3 is tan 180 degrees plus theta, which is positive. So we write T there for tan. Tangent of angle, just tan is a short way of saying it. And then we have quadrant 4, which is cos, that is going to be positive, cos 180 degrees minus theta. You see that? And then we have our cast diagram. Remember, C is in the fourth diagram. Sorry, it's in the fourth quadrant. C is in the fourth quadrant, so it's called the cast diagram. Okay, starting from the fourth quadrant, going to the first, then second quadrant, and then third quadrant. This will assist you. C here means only cos is positive, the other two are negative. A here means all of them are positive. And then S here means sine 180 degrees minus theta is positive, while the other two are negative. And then T here means tan 180 degrees plus theta is positive, while the other two are negative. Just remember that. Okay, so this reduction formula, this cast diagram will assist us a lot when we're doing what? The reduction formula. Right, and then let's say we have our angle, which is 315 degrees. Where is it? In which quadrant is it? It is in quadrant 4. You see that? So that is our angle, 315 degrees. Then it's going to be 360 minus theta. In this case, our theta is going to be 45 degrees. Because if you say 360 degrees minus 45 degrees, you will get 315 degrees. So it is in the fourth quadrant. Okay, and then now, is it going to be what? Is it going to be, if it's tan 360 minus theta, what is it going to reduce to? What is it going to reduce to? If it is cos 360 minus theta, what is it going to reduce to? Okay, so it is in the fourth quadrant. So we can say here, okay, let me just write 45, 360 degrees minus 45 degrees. So it means that if it is cos 360 degrees minus 45 degrees, this is equal to cos 45 degrees, because it's in the fourth quadrant, and cos 360 degrees minus 45 degrees is positive. If it is sine 360 degrees minus 45 degrees, sine in the fourth quadrant is negative, so it's going to be negative sine 45 degrees. And then if it is tan 360 degrees minus 45 degrees, okay, is equals to negative tan 45 degrees. You see that? Okay, right. And then I think we've covered the reduction formula using the cast diagram. Let's look at the negative angles. What are the negative angles? Remember, when I'm measuring angles, we go in the anti-clockwise direction. We go this way when I'm measuring angles, from the positive x-axis. But positive angles, when I'm measuring positive angles, we go in the anti-clockwise direction. But now if you're measuring negative angles, we go clockwise. Okay, so we go clockwise like this. So these are the negative angles. And then negative angles, just know that it's going to be sine negative theta is negative sine theta. And again, you can stick to the cast diagram. Know that in the fourth quadrant, it is only cos negative theta that is going to be positive, because in the fourth quadrant cos is positive. And then cos negative theta is cos theta, and then tan negative theta is negative tan theta. So these two are negative in the fourth quadrant, then this one is positive. So these are negative angles. Remember that. Remember the negative angles. It is only this one, cos negative theta, which is positive cos theta. Okay, right. And then one more concept, then we go back to our question. The special angles. These are special angles. You remember them, but also you can confirm them in using your calculator. And then after confirming, remember, you do your calculations without the calculator. Just confirm, for example, if you have sine 45, just confirm that sine 45 degrees is root 2 over 2. You put your calculator aside and use your root 2 over 2, doing your calculations without the calculator. Okay, right. So these are special angles. Right, let's go back to our question. So now here, if you look at this question, what do we do? Okay, so here this is reduction. You see that is in the fourth quadrant. This is 0, 90, 180, 270, then 360 degrees. So it is in the fourth quadrant. Okay, so it's going to be, this is 315 degrees. So it's going to be 360 degrees minus 45 degrees. See that? Okay, right. And then remember the cast diagram. Remember the cast diagram: quadrant 1, quadrant 2, quadrant 3, then quadrant 4. See that? Okay, right. Now, and then, so we're saying here, this is tan 360 degrees minus 45 degrees. Right, and then we go to sine, this one, sine negative 315 degrees here. I see negative angles, and then when it's negative angles, this becomes negative sine. I'll do each and every step one by one. So negative sine 315 degrees, then minus cos 45 degrees. Okay, right, now we can reduce tan in the fourth quadrant. Tan theta is negative, tan angle there is negative, so it's going to be negative tan 45 degrees. Okay, this is this one, and then let's deal with this. This is a reduction here, so it's going to be negative sine, and then 360 degrees minus 45 degrees, and then minus cos 45 degrees. See that? Okay, I want us to simplify this part here before we change our we use our special angles, right? So it's negative tan 45 degrees, right? And then this is negative sine 45, because in the fourth quadrant sine theta is negative, so it's going to be negative and then negative sine 45 degrees. You see that? So I'm reducing this part here. Okay, so it's going to be negative, this negative, and then the negative coming from what? From the 360 minus 45, reduction of 360 minus 45 there. And then minus cos 45 degrees. Okay, right, again, we can clear this negative term, negative here. So it's going to be negative tan 45 degrees. And then always, if it's multiplication, you can use brackets. Then negative times negative is positive, so it's sine 45 degrees, then minus cos 45 degrees. Now all our angles are acute angles, which are special angles. And then tan 45, if you check, is negative 1, so it's negative 1, put it in the bracket. Then sine 45 degrees is root 2 over 2, right? And then minus cos 45 degrees, which is root 2 over 2. Okay, now negative 1 times root 2 over 2 is negative root 2 over 2 minus root 2 over 2. And then the denominators are the same, so we can add or subtract the numerators. So it's going to be negative root 2 minus root 2 over 2. See that? And then becomes negative 2 root 2 over 2. Like negative 1 minus 1 is negative what? It's negative 2. Then 2 divided by 2 is 1. We remain with negative root 2. That's the answer there. Okay, so it's done. So we are going to meet in the when we do the next question.